Okay, 8.4 probability of mutually exclusive events. Starting off, mutually exclusive. It means cannot happen at the same time. Cannot happen at same time. Okay. We can talk about flipping a coin. If you're flipping a coin, you get heads or tails. You cannot get heads and tails, right? They cannot happen at the same time, right? And that might sound silly, but that's what it is. You cannot flip a coin and get heads and tails at the same time, right? The big formula for this section, and the one that you should at least write down, but I would say you probably should just memorize it, is we're going to say A or B, probability of A or B, right? And that's an inclusive or, is the probability of A plus the probability of B minus the probability of A and B. Big deal here. We have the word or, we have the word and. So let's put this in a real scenario. We're talking about flipping a coin. So we'd say, well, what is the probability, and I'll change colors here, probability of heads or tails? Well, that would be equal to the probability of heads plus the probability of tails minus the probability of heads and tails. So writing in what we know these probabilities to be. Probability of heads for a coin, we've talked about it before, is 1/2. Probability of tails is 1/2. These would add up to be 1, right? 1 is the biggest, I don't know, probability. I don't know how to talk about that. All probabilities would add up to be 1 for a single event. Yeah, that's a good way to say that. So they add up to be 1. So this can't be anything, right? The options are heads or tails, and they have to add up to 1. So what I'm trying to get at here is that if we look at, here's 1 is 1, so we have to have a minus 0 back here. That falls into the place of there, right? So we could say, let me erase some of this and make it a little bit prettier. Probability of head and tail is equal to 0, right? And you could say at the start, well, yeah, it has to be 0 because you can't roll them at the same time, right? So the big idea here that we need to remember is that mutually exclusive events, how do I want to word that? We'll say mutually exclusive events A and B have probability of A and B equal to 0. Yeah. If two events are mutually exclusive, right, the mutually exclusive events are A and B, then the probability of A and B together is 0. And again, you might say, well, that's kind of stupid. I get that. Now, an example that doesn't follow this, that would not be mutually exclusive, say you've got a litter of kittens, and this is an example that Kuda will do, and the kittens could be black or brown, and they could be solid or striped. Okay. You could have a black striped and a black solid. Okay. So that, if I was saying like, what's the probability of black and striped? If I talked about black and striped, I said you could talk about like a Venn diagram. Here's all the cats that are black. Here's all the cats that are striped. Here are the cats that are black and striped. All right. So if I added up the black cats, and then I added up the striped cats, I have to subtract out the black striped cats, right? I had over here we have addition, addition, subtraction, right? You add up the black, you add up the striped, then you subtract the black striped. You subtract the overlap, all right? So hopefully that kind of makes sense. I think after we get a few problems done, it'll make even more sense. Let me take away my highlights. There we are. All right. Starting off, determine if events A and B are mutually exclusive. So anytime they have not A or not B or anything, we want to start off by just writing what is the probability of A. Probability of A, well, it's 1 minus 1/2, which is going to be 1/2. So now we want to just plug into our formula here. So I'm going to say, well, here, I'll write the formula here. Probability of A or B is probability of A plus probability of B minus probability of A and B. All right, we got our formula there. Hopefully we were able to remember that pretty well. And while I was writing that, I noticed something. It tells us the probability of A and B right here. They're mutually exclusive if they're equal to 0. This one's not equal to 0, so this is not mutually exclusive, right? Because this here represents like the overlap in our Venn diagram, right? The overlap has to be 0. They have to be completely separate circles. All right, number 3. I'm thinking that there's something wrong with my... All right, yours here, there's a little bit of a mess up. I don't know why OneNote is doing this to me. This should be 41 right there, not 0, 1. So starting off again, like I said in the last one, normally you want to find out, if it says not A, you want to find out what is A. Well, probability of A here would be 7 over 20, right? In my head, I just did 1 minus 13 20ths, so you have 20 minus 13, which gives you 7. So I plug into my long formula, I plug in what I can. Probability of A or B is 41 over 80. That's equal to probability of A, which is 7 over 20, plus probability of B, which is 1/4, minus the probability of A and B, right? And really what we're wanting to know here is this equal to 0, right? So let me find a calculator and we'll solve this out. 7 over 20 plus 1/4 is 3/5. So I have 41 over 80 is 3/5 minus probability of A and B. From here, I can tell you that this is not equal to 0, right? Because something is going to have to be added or subtracted there to make these two guys equivalent. So right now we can stop and we can say this is not mutually exclusive. All right, moving on. All right, my paper messed up again, but here we are. The thing that we want to look at here is the probability of A given B right here. That means that's the probability of A happening if B happens, right? Or if B has already happened. There's different ways to word that. A is able to happen with B. That's what that says. It happens at a probability of 2/5. So this is not mutually exclusive, right? Because that right there tells us that A can happen with B, or A can happen after B. There's different ways that you can word that. Number 5, looking here, this should be a 2. this would be a 7, and this would be a 0. Here we do the same thing. We say, well, probability of A given B is equal to 0. So that means these have to be mutually exclusive. All right, I'm having lots of numbers messed up here. Yep, that's the way it's supposed to be. Okay. All right, moving on. Number 6, events A and B are mutually exclusive. Find the missing probability. So I'm going to pause the video and I'm going to write in all the fixes that I'm going to have to do, and then I'll come back to it. Okay, number 6. So again, we're going to be going back into that original formula that we have. Starting off, I'm going to write down what is the actual probability of A. The actual probability of A would be 3/5, right? 1 minus 2/5. Now I'm looking at the directions. I don't know if I talked about it yet. Events A and B are mutually exclusive. Okay, they are mutually exclusive. That means that probability of A and B is 0. Probability of A given B is 0. So, plugging into the formula, I'm going to change this guy to be an X. That way it's just faster to write down. X equals probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. But in this case, it's going to be 0. So all I have to do there is add those up. And let me add those up. And we get 17 over 20. There we are. Number 7. Starting off, I write down my probability of B. That's going to be 1/5. And then I probably could have done this first, but I look at what they actually ask. They ask for what is the probability of A given B. Well, these are mutually exclusive, so that has to be 0. So our answer is just 0. Very quick. All right. Number 8. We have the probability not A, so I could write, well, the probability of A would be 2/5. Probability of B is 3/10. It says probability of A and B. Well, these are mutually exclusive, so and can't happen at the same time, so this is going to be 0. Right? Or can happen. There would be an or, but there can't be an and, right? Mutually exclusive can't have an and. Number 9. Starting off, probability of B would be 9 over 20. And now we're just going to plug into our formula. So A or B, 13 over 20, is A, which is going to be X in this case, plus B, 9 over 20, minus A and B, which is 0. So solving this should be pretty easy. We have 4 over 20, which would reduce to 1/5. There we are. Hopefully these 4 are pretty easy to wrap your head around. I understand that some of these up here, it was kind of, I don't know. Whenever I first learned it, I know that I found it confusing. 10, 11, 12. This one just says to find the missing probability. It doesn't tell us if they are mutually exclusive. So we might have to use some information in the problem to know if they are or aren't. Yeah. So we want to plug in and find what we're missing. So starting off, I look at what are we missing, A or B. So I'm going to call that my X. That's what stands all by itself. So probability of A or B equals probability of A, 3/10, plus probability of B, 1/4, minus probability of A and B, which in this case is 9 over 200. So there we are. We just plugged in, and now it's just typing this into my calculator. So 3/10 plus 1/4 minus 9/200. That's going to be 101 over 200. There we are. Next up, again, we're looking for A and B. We'll call him X. And so we have X equals 3/10 plus 1/4 minus 101 over 200. Is this the exact same problem? No, it's not. But I could say really quick, well, this is going to be 9 over 200. I'll type it in again just to make sure. Yep. All right, there we are. Number 12. Starting off, we have A or B, so 39 over 50 is probability of A, 3/5, plus probability of B, that's our X, minus probability of A or B, which is 39 over 50. Oh, I wrote the wrong thing down here. I'm sorry. Over here on the left, I should be using A and B, which is 27 over 100. All right, I'm going to combine like terms on the right side. So I'm going to have 3/5 minus 39 50ths. So this is going to be 27 over 100 is negative 9 over 50 plus x. I'll add that to the other side. So I have 27 over 100. So I think I'm going to get 9/20ths. Is that 9/20ths or 9/200ths? 9/20ths, yeah. And there we are. Lastly, notice that what it's asking for is not B. So I'll say, well, probability of B is going to be my X. And then at the end, we'll have to find not B. So A and B is 11 over 200. Excuse me. We start off with or. I'm sorry. Start off with or. We have 149 over 200 is 11 over 20 plus X minus 11 over 200. Now, whenever I move everything to the left side, I'll have 149 over 200 minus 11 over 20 plus 11 over 200. And I get 1/4 is x. So this is the probability of B. So the probability of not B would be 3/4. All right, that's it.